And without further ado.
Thank you very much, guys. Kind of embarrassing, but you know, I'll embarrass myself more, I'm sure, in a minute. So, have you been enjoying the conference so far? I'll see what I can do about that. So, becoming a better programmer. I thought this talk, I've given it a few different places, and more often than not, it's kind of one of the oddball talks. It's a little bit sort of out there, but the broad range of stuff you've got going here, I think this is probably one of the most sort of on-point programming talks in the conference, which is unusual for me as well. So, a day of firsts in many respects. So, hello, I'm Pete. Thank you for singing to me. I'm a geek. I'm a programmer. Importantly, I'm not an expert. I'm still learning. Very importantly, I don't think I'm stratospherically clever. I don't think I know more than you. I'm just a few rungs up the ladder, learning what an interesting view it is as I get higher up. But basically, in 20-odd years, I've probably learned that as you get higher up the ladder, things get a bit more wobbly, but you get a slightly better view. It's cool. I've written a few books. My first one's called CodeConf. That was about becoming a better programmer. I write a regular magazine column. I've been doing that for about 17 years. That's called Becoming a Better Programmer. And so I then wrote another book, and I couldn't think of a title. So that one's called Becoming a Better Programmer. So you might think, you know, I've either got no originality, or because this talk is called Becoming a Better Programmer, it's a thinly veiled sales ploy. Go and buy my book, it's great. But no, basically, this is just something I'm really passionate about, something I really care about. And so this is what we're going to do today. We're going to work out ways that each of us can become better programmers. So I guess I should probably check, first of all, how many of you guys in the audience are programmers? Show me some love. Good, 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 good. OK, cool. Right. I have some raw material to work with. This is a start. So question number one. Do you, as programmers, or if you're not programmers, as the spheres that you work in, because this applies to you as well, do you want to become better? Do you want to become better programmers? Hands up if you do. Unanimous? Come on, make it unanimous. Cool, good. OK, you're on board. You're on board. That's kind of, that's one of the most important things. And thank you for the enthusiasm. That's cool. Question number two. Does it even matter? Does it? Cool, yes. Why? See, it always goes quiet. Because you're not good enough. OK, then that's cool. Usually I get some kind of sarky answers. One, not the only answer, but one really very good reason is because you don't want to be the guy that makes people go, ah! Now, we've all worked with them, yeah? The guys that just spew out dodgy code, the kind of code that just gets in your way, that distracts, that slows you down. You don't want to be that guy. That's, if nothing else, one good reason. Not just your sanity, but the sake of humanity. OK, so here's my premise. This premise has been running through, you know, this is what I've learned from 20-odd years in the industry. I know I don't look old enough. My premise here is that becoming better, being a good programmer, more than anything else, is about attitude. Ooh, it's a bit handsy, sort of wavy, touchy-feely stuff, I know. But it's just my observation from the people I've worked with, from the people I've learned from. Now, a long time ago, I was sort of told a little, given a little illustration, and it stuck with me for years. And it's attitude, you can think of it like three axes. Now, not those kind of axes. The kind of axis of a plane. So you know, I'm not a pilot. I know people who are helicopter pilots, and they tell me this isn't wildly off. But a plane moves on three axes. You've got the pitch, the yaw, and the roll. Don't know which way around they go, but you've got pitch, yaw, and roll. That is called, the position of a plane, the trajectory on those three axes is called its attitude. And this is the interesting thing. If you apply pressure, if you apply power to that plane when it's even got a slightly wrong attitude, it will massively miss the mark. I just think that's an interesting illustration, that if we don't approach the act of creating code, the act of creating software with the right attitude, we could massively miss the mark. Cautionary tale. And Winston Churchill agrees. Attitude is a little thing that makes a big difference. Now, you know, just if you want to sound like you know what you're talking about in any talk, throw some good quotes up there. Yeah? So Winston Churchill, clearly, you know, you're going to trust him, British Prime Minister. Very, you know, but maybe he was just one guy agreeing with me. Scottish playwright Walter Scott. For success, attitude is equally as important as ability. This must be true. OK, Muhammad Ali, another great philosopher. To be a champion, you must believe you're the best. If you're not, pretend you are. Is that a good attitude? OK, it's good to have a can-do attitude. It's good to believe you can do something, even if you've not learned this thing yet. I think I can do it. On the other hand, pretending to be good. Is that good? Maybe not. So it's not just having an attitude, it's having the right attitude. And that's the kind of thing that I just want to spend this 40 minutes trying to unpack. 40 minutes, by the way. I know this is a luxury compared to some of what the other speakers had, but for me, I'm going to have to condense and condense and condense. So I really hope I get enough information for you in this 40 minutes, because normally this talk takes like 90. So here's Goodliffe's taxonomy of programming shenanigans. In the sense that, what we do as technologists, we start from a basis of knowledge. We learn, and we learn facts and whatever, about the technologies we work in. Then we learn the idioms of how to apply and use those technologies in certain areas. So the idioms. Then we learn the application of those idioms and the technology to problems. And that's what we do. And it's great. But I'm just re-saying it again. If we don't sort of have the right attitudes, if we're not applying those things for the right reasons, it's not for, to make me look good because I want to learn this, but because it's the right application of the right technology in the right place, then we're missing the mark and we're doing the wrong kind of work. And again, that's that kind of thing from going from knowledge to wisdom. Why we're doing something rather than just how we're doing something. So, how do you get better? Do programmers, like a fine wine, mature with age? Or maybe, like a cheese, we mature, get slightly smellier and get a few veins. Let's see. Obviously, how to get better. Learn technology, that's a given. Learn the idioms, that's a given. Learn how to apply it all, that's a given. But more importantly, work out how to adjust your attitudes, or take an audit. Let's look at what we do. Hand wavy, I know, but I think this could have keys to really help you get better. Stick with me. This is the ninja level kind of stuff. If you're going to quote anyone, I'm going to quote myself there. This was for the intro to my book. There's more to being a great coder than simple understanding of syntax and the mastery of basic design. The awesome programmers, those productive people who craft beautiful code, work effectively with other people, know far more. There are methods of working, attitudes, approaches, idioms, and techniques you learn over time that increase your effectiveness. There are social skills and a whole pile of tribal knowledge. We need to sort of gather all of that up, and work out how to improve. But the first thing is to want to improve. And you stuck your hands up, you want to get better, yeah? So, cool, we're on board. This is what I want to try and unpack. I'm going to show you a few models of learning, of knowledge acquisition. This ties into attitudes, and we can use these models to help us work out what to learn. I'm not going to give you many very practical, this is how you put a semicolon here, or this is how you should indent, or this is the library you should use kind of stuff. I want to give us a framework to work out how we can find information and use it to the best of our advantage and our project's advantage. So then we'll look at what you should learn, maybe some specific topics if we have some time, and then more hand-waving to wrap up. So, the models of knowledge acquisition. I think this stuff is really fun and really interesting. So, here is a hypothetical model of learning. It's bobbins, but just go with me. There's you at some sort of period in time. You know what you know now, and it ranges from down here, utter liability, the coder, to super awesome guru, genius programmer. You're here at this point, some point in time, this is what you know now, and you would like to get better. Cool, okay, that's our first model. It's rubbish, because knowledge applies not just in one branch, not just one area, but it's per skill. I may know a load about C++ and nothing about JavaScript, yeah? So I need to work and learn differently in the area of C++ than I do in JavaScript. Just even understanding that will change the way you absorb new knowledge. But let's go beyond that. The next model, or an actual model. The four levels of competence, although because I'm a Brit and my glass is half empty, I'd like to say the four models of incompetence. Something that was formulated in the 1940s by a psychologist called Abraham Maslow. Have you guys heard of this, the four levels of... A few of you? Cool. So, he observed these four states. Unconscious incompetence, conscious incompetence, conscious competence, and unconscious competence. You repeat after me. Yeah, so a good example of this is driving a car. Yeah? When you're 2 or 3, you have no idea, really, what's involved in driving a car. You're aware that your folks drive a car, but you're there maybe sitting on the back with a plate and you're doing this, and you're thinking, if I just had the plate in the front seat, I could drive this car. You have no idea how you're so totally wrong. You do not know that you do not know. And then as you get older, you get closer to taking a driving test. you begin to realize, you begin to learn, and you begin to understand how much you don't know about driving a car. There's so much involved. Now, you guys have it easy with automatics, but in the UK, we've got the clutch to deal with as well. And it's like, how many things can we move at once? And you've got to be aware of the road. And oh, my word, this is complicated. I'm a conscious incompetence because I know how much I don't know. That's a really good place to be. And then you get to conscious competence. You learn, you practice, you learn, you practice, and you become competent. You can now do this thing. You are consciously competent. But the important thing at this level, which is another great place to be, is that in order to exercise this skill, you actually have to think about it. You have to still concentrate on driving. And so that's you after you just pass your driving test, yeah? If you don't concentrate, boof, you ding the car. And finally, after you've been doing it for so long, you get to this level of unconscious competence. Now, that's not necessarily the guru state, and this is a piece of warning to heed. If you are unconsciously competent, you don't have to think about doing the thing, you just work on intuition. But as a driver, if I'm not thinking about what I'm doing, I may not be paying full attention. I may actually not notice the kid stepping out in front of the car in front of me. I might knock into them. So sometimes conscious incompetence can almost be a dangerous place to be. So it's just an observation, but that's a model that we can hang our learning off. Next one is the Dunning-Kruger effect. Now, I'm an expert at this, which is a hilarious joke if you know anything about the Dunning-Kruger effect. Thank you for laughing. So the Dunning-Kruger effect is a cognitive bias. It came out of some 1999-odd experiments at Cornell University by David Dunning and Justin Kruger. And it works like this. Basically, they observe from a whole load of study that people who are unskilled, this is the 4 levels of incompetence again, the people who are unskilled consistently rated themselves above average in the thing that they were doing. So if you gave, if somebody starts working on JavaScript and they spent a few weeks on it, they then think, oh yeah, I know this all, I'm really good at it, when they know nothing. And yet these skilled people with the body of knowledge, they know so much, they also know how much they don't know. Those are the guys that rate themselves under average. And this is a dangerous thing. And this kind of explains maybe some of the, you look at the composition of your team, and some of those people you might think, well, they're not all that, but they really think they are. This is the Dunning-Kruger effect. They believe that they're over average because they don't realize how much they don't know. Unconscious incompetence again. Their observation was the miscalibration of the incompetence stems from an error about the self, whereas the miscalibration of the highly competent stems about an error made on your judgment of others. Interesting stuff. So Confucius, he say, real knowledge is to know the extent of one's ignorance. This is cool. The next model is the Dreyfus model of skills acquisition. This is the biggie. This is the biggie. This is really interesting. This was like a seminal model. It came from 1970s research. I think the Dreyfus brothers proposed it in about sort of 1980, I think it was. But what they observed, they built up a taxonomy of learning, and they observed that the changes at each of these different levels, there was a way that you would think and perceive the world, and your mental models were different, and the way you needed to learn was different. So this is gold dust. Pay attention. They split it up into sort of these 5 levels of understanding, where you go from sort of chimpanzee to concert pianist, I think. But they are novice, advanced, beginner, competent, proficient, and expert. I wish I could go into more detail about this, but these are all really interesting things to unpack. If you're a novice, you know nothing about the subject at all, obviously. So so I don't know anything about how to set up Fabricator, say. So what do? I Google for it. I find some instructions, and I follow those instructions. That's what I do. As a novice, I just want a rote set of rules, and I'll follow them, step by step. I have no idea if they're good. I have no idea if they're bad. As long as I get results, I'm happy. I want results. I will, as a byproduct, learn from those steps that I follow, but at the moment I have no understanding of the subject area, right? That makes sense? Next, the advanced beginner. Now, these guys are sort of beginning to sort of understand the rules. They break them every now and again. Oh, that step on Google, and I Googled this page, and it doesn't quite apply to what I'm doing, so I'll try and change that configuration parameter. Maybe it's something else. Oh, that didn't work. Okay, go back, try something else. They begin to break the rules, but they're still working the framework of rules. Easily get stuck, but you're beginning to explore the space. You're beginning to understand a little bit about the subject area. The important thing there as well is an advanced beginner knows where to get answers. And here again, Google is our friend. It makes a big difference to know the search terms to look for, even if you don't know the pages are telling you. You've got a handle on where to find the information. A load of us are at this position, and as long as you're aware that because this is per skill, as long as you're aware you're an advanced beginner, so I know nothing about Node.js, but I know how to kickstart myself into those areas, that's cool, you're aware of it. Then we move on to the competent level. Now, this is where most people stick, actually. But you don't need to follow rules. You have a mental model. You can plan new routes into problems. You don't have to just follow a rote set of steps. And you can also begin to solve sort of unknown problems, things that you really weren't expected or that were outside of your frame of reference right now. The competent level is a really great place to be, and it's where most of us get in most skills. I expect that in a lot of the things you do, you are competent. Congratulations, you're competent. So then, beyond that, they observe the proficient level. Now, this is, you're really beginning to become an expert. You're really beginning to delve into the subject area. You know how you can expect the unexpected. You can begin to pull the information together and sort of you have a bigger world picture. You can interpret maxims, which is sort of rather than here are the rules, this is how you do something. This is the general way this works. These are our idioms. These are the ways we do things, and you can begin to interpret those rather than just follow set rules. And you build up the tacit knowledge, the kind of stuff that isn't written down, but after playing with the technology for so long, you begin to realize how it works. Those proficient guys, the people that when they leave your team leave a hole, even if you got them to do a big document writing down everything they know, that tacit knowledge is what you would lose, and that's why these kind of guys leave a hole in your team. And then finally you get that expert, the guru guy. And it's not just he's been doing it for so long or she's been doing it for so long that they're an expert, but you have authority and you understand how this particular technology ties into all the other technologies, the landscape that you work in. The important thing about an expert, now you're really working from intuition. You see a problem and you just kind of know how to solve it. You can't even begin to enumerate the steps. And, well, obviously, I thought I'd do this, then I'd do this, and then I got to this solution. The solution's just there. And you guys know this, yeah? Sometimes you have to think through a problem and it's really complicated, and sometimes you just look at a problem and go, yeah, that's the way to do it, and you can't necessarily explain why. That's kind of moving towards expert level. Now, why is this important? Well, I think it's interesting for two reasons for us today. One is it's really helpful to use as a framework for your learning. If you need to learn about something new, as I say, a new technology, understanding where you are on that scale helps you to understand that you need different information. So if I know nothing about that, it's all right to Google, find a list of steps and just follow them slavishly, understanding that you're a novice. Whereas if you're an advanced beginner or if you're competent, you're going to be looking for different kinds of information. You're going to be asking different questions. Just being aware of that is important. Also aids teamwork because clearly an expert works in a very different way from a novice. In fact, no, you can use this for evil. If you pair program, it's really, really good fun to pair an expert with a novice because the novice doesn't understand the intuition that the expert has. The expert gets really frustrated with the novice, and if you do it really well, it can end in a fist fight. So you can use this stuff for evil. So that is the Dreyfus model, and this is a really useful framework to work in. Remembering again that it is per skill. There's a load of other sort of frameworks we could talk about. Just a couple of others that have some value to us. How many of you have read The Pragmatic Programmer? A few of you, yeah. It's a wonderful book. Go read it. They have one vivid metaphor. I've given this talk in banks, and I've been really fearful because I know nothing about finance. But they didn't quite laugh me out the bank. So the Prags have this picture of your working set of knowledge as an investment portfolio. And you need to tend that investment portfolio. If you just ignore it, it will rot. It will decay because you're not sort of investing, you're not curating it properly. Now, a portfolio has a finite size. There are some things that you're bringing in, and there should be some things that you're retiring. You want to make a good spread of investments in your knowledge. So there are some things that are probably not that risky an investment. So, hey, JavaScript, everyone needs JavaScript. However, it's not a risky investment. It's just if you learn that, you'll be on the gravy train for life. It's a worthwhile investment. On the other hand, there may be some other high-risk investments that are worth adding on to that. So some areas that you just have no idea about, or that are just fledgling languages or new technology stacks that may or may not succeed. But if you invest your time in them right now to learn them, you may have a competitive advantage over somebody else. You should have a nice spread of investments in your portfolio, the safe investments and some higher risk investments. And the idea there is curate your portfolio, purposefully take maybe some of those high-risk investments that didn't pay out, and put something else in its place. You've got to think about your risk-reward balance with what you've got going on there. Again, just doing that practically really helps you to improve. Who knows what this number is? Hours. 10,000 hours, yes. It's kind of bunk, to be honest with you, but it's good to wave your hands and talk about it for a bit. The idea that 10,000 hours is the number of hours of deliberate practice, where deliberate practice is a very different thing from just playing. Deliberate practice that's required to become an expert in something. That number was made famous by Michael Gladwell in the book Outliers, but that came from some research done by K. Anders Ericsson in Berlin, I believe. And what Ericsson did was studied highly skilled areas. I think it was violinists, like concert violinists, and at a musical institute. And what they observed was the guys who'd invested 10,000 hours of practice, since they were knee-high to a grasshopper, those were the experts, those were the virtuosos. The guys who put 8,000 hours in, and again, there's not much difference really. Well, 2,000 hours is quite a lot of practicing the violin, frankly, but by the time you're that good, you're probably doing it in your sleep, so that's fine. 8,000 hours, those are the people that were ranked showing potential. And the thing that makes me laugh is the 4,000 hours people, they put down as good enough to be music teachers, which I think my piano teacher wouldn't particularly like. But the interesting thing from that study, and so the number is up for debate, 10,000, I think Ericsson himself didn't necessarily say it is 10,000, it's just what the study showed. It's kind of the shape of the problem. But it kind of goes against, in some ways, the notion of inherent capability. Some people are just born to be programmers and others aren't. Well, no, to be an expert in any field, you really have to try. You really have to invest expertise. You have to invest practice, deliberate practice. So shove that in your learn C++ within 24 hours pike and smoke it, frankly. That 10,000 hours, so, there's a debate over it, but that's basically 3 hours a day for 10 years. That's a lot of effort. So, and their observation was basically, you have to start, to be an expert in something, you really have to start practicing as a kid and work your way up. All that is saying is now, if you're going to learn something new, don't necessarily set your sights so high that you think you're going to become an expert. Maybe you will, but it's all right not to be, because in order to invest the amount of time you would need to become an expert, it might not be worth it. Be realistic about your expectations in how you learn. So the final one, this is my model of knowledge acquisition. Who knows about the 5 stages of grief? Can anyone name them? You get a banana. So, denial, anger, bargaining, depression, acceptance. My observation is that learning is like grief. They're both better when you've got over it, but stick with me on this one. I've got a problem I've got to solve. I don't know how to solve it. I've got a new technology I need to learn, new problem. Denial, first of all. I don't know. I don't need to learn about that thing. I can solve the problem without it. No need. It's going to take me too long. It's fine. Anger. Oh, no, I have to learn this thing. That's really annoying. It's going to waste me loads of time. Bargaining. Right, okay. I'm going to learn as little about that as I possibly can just to get by. Depression. Oh, cripes. It's too big. I'll never learn all this stuff. It's going to take me forever. Wait. Oh, okay, it's not that bad after all. Now, I actually think that's a thing that we go through. Like, we do many ones of those daily, and over weeks we do this all the time. This sort of denial, anger, bargaining, depression, acceptance cycle on learning new technologies. As I tell people, I'm one of the guys in my office when I first said this one. I've just done that today. I've gone through it twice in one day, and it's like, yeah, it's what we do. So These are things that we do, but these are things that we have to do in order to become better, okay? So those 5, 6 models are the 3 pillars that the rest of this talk is based on, which is what should you learn now? So remembering that you understand your sort of taxonomy of learning, where you are in certain skills and how you need to learn in those skills, what should you learn? Where should you invest that 10,000 hours of deliberate practice? Well, here, programming is such a huge and vast field. This is actually one of the reasons why I love programming. There's always something new to learn. There's always something different. I'm never stuck in one rut. I never have to just plow one furrow. Yes, my book is there because basically this is the point of the book, was to unpack areas that you can learn to become a better programmer. So whilst it would be easy for you to just buy it, and that's, that'll save you 10,000 hours clearly, the areas that I identified there, that as programmers we can invest some effort in. Writing code, clearly, the practice of programming, personal skills, and how we work with others. So by writing code, and here's the thing, as I just sort of run through a list of a few things, think which of these may apply to you the most right now? Are there some things you think, yeah, I've got that down pat, that's fine, but there are some things that you think, oh, I could invest some time in that. Like code presentation, avoiding unnecessary complexity, writing robust code, working with familiar code, good design, removing code, handling errors well, all this kind of stuff. The act of writing physical lines of code, this is our bread, this is our butter, this is what we do day in, day out. If you're not purposefully investing effort into trying to do that the best you can, identifying areas that I'm good here, but I'm a bit weak there, I'll put some time in, I'll try to learn from some other people, then you're not doing yourself a service, basically. So then we step wider, the practice of programming. Those things, rather than just the lines of code, but the ways, the techniques that we fit around them, the development practices, the skills, the way we work as a tribe. So knowing kind of what software development really is. It's not playing with code, it's something so much bigger. How to use your brain, how to solve problems in a sensible way, rather than just running at a problem and just going for the first solution that occurs to you. Effective use of version control. Some people, well, GitHub, yeah, cool. Some people suck at this kind of thing. Ideas of working with QA, for example, treating them as equals, not as a team that you throw code over the wall to, but fully embedded. Code reuse, what does it really mean? Is it something that we just try to build in when we first write a piece of code, or is it something that emerges? Ways of making good software releases, the tribal skills inside your organization, all those kind of things are another whole area that we need to focus on and purposefully invest effort and time. Then personal skills, how to learn. So this is kind of what this talk is about, how to actually learn. If you don't have a framework that you can gather knowledge and take new knowledge in with, then, I read a book, off it goes. Acting ethically. Seriously, that's an interesting one for the programmers, and was one of the reasons my book got commissioned. How to solve problems well, smarter not harder kind of stuff. How to learn new languages quickly, how to avoid stagnation, this kind of stuff. And how to work well with others. We very rarely work on something alone. As programmers, we're working with a team to achieve a shared goal. That requires skills. So accountability and sort of the ways of dealing with conflict. Now, that is the sign of mature developers, because you will never agree with everyone all the time. But it's how you deal with conflict. You can treat conflict as a source for good, as a way to get to better designs, as a way to work better together, or it could just be the worst thing. It could destroy your team and then ultimately ruin your software project. So there we go. So that's just me saying a whole load of stuff. We haven't looked at anything in particular, and basically in the time we've got, I can't unpack a whole load of things. However, let's just look at a few perhaps, understanding that, again, we know how we learn, we have this model, and we desire to get better, we desire to program better. And with my underlying thing, that it's the attitude with which we do these as well, rather than just some kind of techie thing, I'll just learn this and then I'll be better. a few little areas that are worth thinking about. First is writing less code. And to programmers, this seems like an oxymoron. Why would I want to write less code? But no, it's perfectly possible to write less code and to have more software. Do you agree with me? The idea, we work with so many people that write so much boilerplate, so much scaffolding, so many vapid, pointless comments that just got in the way. So many bits of waffly, pointless logic that just could have been reduced to a simple, virtual dispatch on a function or something. We can use our tools better, write fewer lines of code where there are fewer bugs, and have more software. That is something we should strive for. Definitely a case of one of those things of working smarter, not harder. So cool. Then the ninja level beyond that is improving code by removing it. How many people are delighted when they remove code and make things better? Yeah, you're with me. Just the other day, I took some code from a coder, hundreds of lines of the stuff, spaghetti logic this was for loading files, and it defined virtual hierarchies of things and families of file classes and pre-file loading callbacks and post-file loading callbacks. It was all unused, pointless rubbish. Removed the whole lot, replaced it with 3 functions: load file A, load file B, load file C. Win! You could read the code. You could actually, we removed a whole load of bugs in the process. So yeah, improving code by removing it, knowing, and so then we think about the attitude, knowing when to do it, how to do it well, and the attitude we have to the coder who did that. Were they an imbecile who wrote stupid code who I should then look on with derision and despair? Or were they less experienced? Maybe they were an advanced beginner and didn't know better. Or maybe they were solving a problem that was about to exist. They wrote the code, and then for various reasons, that project, that's sort of the reason for it went away. So there's your attitude thing. How do you deal with that? Do you write a really snotty check-in message saying, remove this crap? Or do you just go, okay, that's cool, we've made the code base better. We've learned. So that's one area. The next, taming complexity. Now, here's the thing. You may not know this. Software is quite complicated. Yeah? That's why we're paid the megabucks. Yet, there are kind of two types of complexity in software. There is the necessary complexity, that is the bit that we're paid the megabucks for, and kind of in the same way as those meaningless, waffly, pointless lines of code, there is the unnecessary complexity. And again, it's understanding the difference between unnecessary complexity and necessary complexity, knowing how to craft something suitably complex and not solving the problems you do not need to solve yet. Appropriately complex design solves the problems and gives you a framework and an ability to defer unnecessary complexity, the problems you may not need to solve. Complexity manifests at many levels, in lines of code, in the designs of our class hierarchies, and at the global scale and the architecture. So here's a suggestion: strive for simplicity. But again, this is the experience. This is what we learn as we go through the programming game. If you just go for simplicity, if you just aim for simplicity, you might miss and get simplistic. And it's understanding that, where, yes, you don't want to write needlessly general code or implement features that aren't needed right now and may never be needed. On the other hand, if you omit something that's really important or do a slightly bad job because it was going to get too complicated for me, then you end up with simplistic code. You get code that doesn't work. And again, learning to understand, identify, and have a feel for that kind of stuff. Sometimes it's intuition, and sometimes it's something we really have to work on. How good are you at that kind of stuff? Think about the Dreyfus model. Sort of, where do you sit in this sort of area of skill, in this area of programming? Maybe you're up there, maybe you're down here. Another one. Now this is cool, and it's very unprogrammer. The art of good communication. Programming is all about communication, yeah? Code is communication. We're talking to the compiler to tell it what to do, or to the interpreter to tell it what to do, to the scripting engine to tell it what to do. But we're also talking to other programmers, explaining how the system works and where we're going forward and how they can extend this code. We're also talking to ourselves 10 years down the line when you pick up your own code and go, what idiot wrote this? Oh, it's me. So communication is a vital, vital skill for programmers. So again, how good do you think you are at this? Think about it. Communication is a skill. It's a skill that requires practice. Do you understand how the different communication mediums sort of play out? When's it better to codify something in, well, literally to codify something in the code, to put it in comments or documentation next to the code? When is it appropriate to have a conversation in email? When is it more appropriate to use Skype or to phone someone up? When is it more appropriate to go around to someone's desk with a baseball bat? You know, there's different communication mediums, and it's genuinely a skill to use the right one in the right context, to talk to people in the right way as well, with respect, but clearly. Sometimes you need to get problems solved, and I know some guys who just kind of steamroller in there and sort of like guns blazing up to the desk. And you're never going to get to a solution. You're never going to solve a problem. You're never going to collaboratively work together because you're not showing respect and you're not listening. This is something that programmers at any level can always think about and work on. I highly recommend you just spend a while thinking about that. Handling messy code. I find this one a good example, again, of the programmer attitude and how it affects what you do. Jean-Paul Sartre almost said, hell is other people's code. Yeah? How often do you pick up some, you check out a project, you look at it and go, ooh, I can probably use it, but I wouldn't have done it like that. In fact, if I'm going to use it, I might have to rewrite the whole lot. Maybe you do. But then again, maybe, as soon as you do that, what's the judgment call you make? Do you look at the other coder? Or do you look down on the other coder? Again, do you think, imbecile, I could do that better? Maybe you can't do that better. Maybe there's a good reason for it to be in the shape it is in. Don't make snap judgments. But then, once you've done that, do you replace the code wholesale? Do you work with that person to improve the codes, to get it to a better place? There are many approaches you could take. And the right approach will be dependent on the context, and that'll be dependent on your experience and your maturity and your attitude. It's collaborative working to get the best software possible, to work as a team as best as you can. I think this is my last one, avoiding stagnation. Now, you guys, I mean, this is when the audience that comes to a conference that wants to learn about stuff, you're not the guys at the moment who are likely to stagnate. You want to learn new stuff. You want to exchange ideas. You want to meet up with other coders. You want to be fired up. You want to be engaged and encouraged to keep going in this cool career that we've got. Awesome. On the other hand, you do kind of have to be aware that some days are better than others. Some weeks are better than others. Some years are better than others. And if you're not careful, if you kind of lose that passion, you can become a coding dinosaur. If you want to avoid doing that, you have to take specific steps. Maybe you're deliberately practicing some really techie, kind of complicated skill, and that's boring the pants off of you now, and it hasn't become fun anymore. You've made a promise to yourself you wanted to learn this thing, but it's becoming a drag. Maybe that's, that's leading you to be in danger of sort of falling out of love with programming. Maybe it's time to reassess. Maybe it's time to change. Look at something else. It's kind of all about being passionate, about loving what you're doing. I genuinely believe so those kind of attitudes that define good programmers, the humility, the caring about coding, the wanting to work well together. One of the key ones is being passionate about what you're doing. Desperately loving to write the best code you can because that's your source of enjoyment, that's your source of engagement. Whatever you can do to stoke the passion. Drinking with other coders is a great one. So, as I begin to bring this into land, what have we done? We've looked at some models of learning which kind of shape how we learn and how we can become better. We've looked at some areas, the wide gamut of areas that we could become better in. And I'd like you to sort of genuinely walk away and think about some specific things, some specific areas you can get better in. And we sort of shot through some sort of specific ones as well. But as I say, here's the thing. Oh, another eminently quotable person, I think most every quote on the internet is probably attributed to Albert Einstein at some point or other. But anyway, any fool can know. The point is to understand. What are we going to do? We want to become better programmers. You said that you wanted to become better programmers. Go you. So what are we going to do about it? Every talk should have a quote by Dr. Seuss, because Dr. Seuss is cool. The more that you read, the more things you'll know. The more that you learn, the more places you'll go. Learn, learn, learn. Remembering that it's all about attitude, yeah? So this good attitude, as we're learning, shapes your code, it shapes your career trajectory, it shapes your team, it shapes what you're doing. So we're aiming for those healthy attitudes that foster a real desire to learn, to be better, to work better, to craft better code. Chinese proverb. Learning is like rowing upstream. Not to advance is to drop back. If you're not learning, if you're not trying to improve yourself, you are dropping back. You are going to stagnate. You're going to become a code dinosaur. Although it would be quite cool to be a stegosaurus, I suppose. But you don't want to be a code dinosaur, whatever I say. So again, I ask you, genuinely, do you desire to become better? Yay! Do you want to work better? Do you want to write better code? Is that what you want to do? I trust that you all do, yeah? You care. You care about code. So what will you do now to improve? What kind of areas? You've been to this conference, you've seen a whole load of different technology, a whole load of different things. Some of those things you're not a novice in. Some of those things you're an advanced beginner or you're competent. Those are the things you know about. It was interesting, it was informative, but it wasn't new. Some of those areas were entirely novel to you. Some of them will have piqued your interest. Invest in a knowledge portfolio. Look at some of those things and go, right, that looks cool. Science hacks, that's cool. I'm going to do that. Some things you need to retire from your portfolio, so consciously retire them. Remembering that this is sort of per skill in the competence. So think about some things maybe from this conference that over the last 2 days you're a novice in, and commit to putting some time to learn more about it. Some of those things that you're a journeyman in, that it's your stock in trade right now, continue to invest some time in and actually have a, rather than just, I'm learning because I'm doing it at work, invest some specific time. Get some new books. Listen to some podcasts. Something that's actually going to improve your skill level in the thing you're doing right now. And if you are an expert, well, good on you. Maybe you should be, not necessarily, don't ignore it, but don't put so much effort into the stuff. Maybe you're an expert in that area and you find it super fun, but maybe that's not where you're going to get your most bang for the learning buck, yeah? So, again, tell me I forget, teach me I remember, involve me I learn. You have to do this. I can sound enthusiastic and I can talk about learning and stuff, but unless you engage with it, unless there's a specific thing that you want to do, that you identify that you can do, and you commit to doing it, then it's just a bit of talk, it's been words. So another suggestion to help you sort of put wheels on this, become accountable to someone to improve in that skill level. So say I want to improve in teamwork. I think I don't listen to people well enough. I realise that. I'm going to become accountable to someone. I'm going to say, right, this is an area I want to work in. I want to learn in. A, if you see me not working well here, tell me. And B, ask me in a month's time what I've done about it. Accountability will really help us improve in here. So skip those. Again, it's this practical question. What are you going to do now? What are you going to do? What are you going to commit to yourself to do to improve your level of skill in many of those areas that we talked about? And in case there was sort of any question about the best way to help you learn, it's a good book. Just saying, thank you for listening. I've enjoyed it. Right, I want to do this. We're in Nashville. It's the home of music. I did this in one conference before and it really worked. Nursery crimes, okay? I'll explain what they are. It's a joke, yeah? Something to do with music, something to do with nursery rhymes. Now, I've got no idea if the nursery rhymes from the UK translate to the US. I'm really hoping they do, or this isn't going to work. But, some premise, my daughter, she needs to go to sleep, and I need to teach her to code. So first of all, Mary had a little lamb. Do you guys know that? Cool, okay. This is how it goes. Mary had a little lambda. Its function was pure but slow. And everywhere that Mary applied it, the lambda was sure to eventually return a result. Now, you kind of get the idea, you kind of get where this is going, yeah? One more, and this is why I want to try. Humpty Dumpty, this works here as well, yeah? Cool. And you sang, I heard you sing, so here we go. I need you to sing along with me, okay? You game? Yeah? Humpty Dumpty built code with all, but Humpty's code was not clean at all. All the team's coders, both women and men, couldn't get Humpty's code building again. There we go. You could have sung a bit stronger, frankly, but it worked. And now I have shut up. Thank you.